So today, me and me Radul Dotto and Shashwata Mitra will present on the pin configuration of 8086 microprocessor. And Shashwata will begin with the main pin configurations. Then I'll go for the mods. Previously, we have learned about the architecture of the microprocessor. So today we'll only know about the pin configuration and how what in what pin what works.
Okay, as we have learned in the earlier class, the Intel 8086 microprocessor is the enhanced version of the Intel 8085 microprocessor, which was designed in 1976. It has a 16-bit configuration. So the pin configuration, as you can see from here, it has two ground pins at pin number 1 and 20, and it has a power supply for the plus 5 volts voltage at the pin number 40. So we can basically divide the pin structures for in three different groups. We have the common signal pins, which are common for both the maximum modes and the minimum modes, and then we have different pins for a set of pins which are for the maximum mode, which are from 24 to 31 in the right hand side, and left hand side these pins, similar pins are for the minimum mode. What do you mean by bidirectional? So bidirectional means it will the input the pin that has the bidirectional signal. It has both. It will receive as well as receive from what? Receive from the receive data from the source.
Means receive data from the
Receive data from any data source, and then
Data source means
suppose from it will receive any signal
signal. Receive
data.
and what?
Receive, and it can also give it back input as well as the output.
To what?
It will so basically it will feed the input and output.
This is from what?
means actually this is the main work of address buses, which are
Address and
data buses, which are bidirectional. Means it will transmit the data to the suppose data transreceiver, and also will receive the feedback also. Means it's a two-way process.
I am just asking you from what it should receive the data and to what it will send the data.
From the CPU, mainly. The CPU, the processor.
Nothing else.
Yeah, from any external device if wants to connect.
Talking about data, it should be sent to CPU.
Means if the there are two kind of thing. Means if the DMA wants to work, the direct memory access.
Can you tell me the IO these things? How the IO ports are being attached to this microprocessor?
Input output ports.
IO devices, input output devices.
Yeah, we have included it in the next part. Means we have done the how it works.
To that slide and show us now from what it should get the data and to where it should send the data. Okay.
So so I will be first discussing about the common pins which are for both the maximum and the minimum modes. So first we have the address and data buses, which are AD. So basically what we have already learned is that bus is basically a receiver of the which helps in communication. So address buses are used in order to carry any sort of data from a particular memory location or the input output location from the microprocessor. So in case of the 8086 microprocessor, we have a low order address bus which is multiplexed with the data buses. So it is a 20-bit 20 line address bus. So it starts from A0 to up till we can see that there is A15 at pin number 39. It's not been marked. And during memory address transmission, it is written as just A. And the data buses are given with the symbol D. So the data buses have 16 lines. So next we have the BHE, this pin number 34. which is the which BHE stands for basically the bus high enable, and S stands for the status. So it is basically an input type pin, and it is basically a 8-bit device which gets connected to the upper half of the data bus. So next we have the minimum and maximum, which helps the microprocessor to indicate what mode it is working on, whether the minimum mode or the maximum mode. And we have the read pin, pin number 32, which is used for the read operation when it is active in low conditions. So next we can see that pin number 23 is the test. So test basically what it does is that when basically 8086 will enter a buffer state, like it will wait only wait instruction, and it will again continue with the execution only when the test mode is low. So when the test pin gets high, the processor remains in the idle state. Then we have the pin number 22, which is ready. So basically it is an acknowledgement from the memory for the data transfer. If the ready is at low, so the processor will enter the wait state, and if the ready is high, then it will have the idle state or no effect. The next we have the reset pin at pin number 21. It causes the processor to immediately terminate its present activity, and the signals must be in active high for at least 4 clock cycles. So that is the function of the reset pin. So next we have the clock CLK at pin number 19. So it is known as the clock input, and it provides a basic timing that the processor operation has control activity. And so basically there is a 33% clock cycle, which means the signal will remain high for 1/3 of the entire clocking period. So next we have the interrupt request at pin number 18. So this is a triggered input, which basically it is sampled during the last clock cycles of each instruction in order to determine the availability of the request. So if any input is pending, the processor will enter the interrupt acknowledge cycle, and the signal is active high and synchronized. So the minimum and maximum things.
Okay, thank you, Shashwata. So until now we were talking about the common pins, right? Which work in both minimum and maximum signals. But now we're gonna talk about the minimum and maximum modes 8086 microprocessor take. Okay, as mentioned by Shashwata, that this mode exchange or mode availability depends on the MNMX pin. What is MNMX pin? If the MNMX pin gives an apply logic of 1, then my microprocessor works in the minimum mode, right? And if the logic is 0, then the microprocessor will work in a maximum mode. So in the minimum mode, the basic difference between the minimum mode and maximum mode is that the minimum mode does not get associated with other co-processors, right? It does not have other multiprocessors. But in case of the maximum mode, we have more than one multiprocessor or co-processors can be take place, right? So now talking about the minimum mode. So minimum mode, what is minimum mode? It means when the pin is the MNMX pin is tied to the VCC, that is the voltage out in the source, that it's greater than +5 voltage, and when it's equal to the logic gate 1, then we can say that the processor is working in the minimum mode. How we can determine that it's in 1? Because MNMX, if it's 1 equals to 1, then the minimum will form the 1, then it's in the minimum mode, right? So for the working in the minimum mode, we first we want to learn about the DTR and the DEN. What is DT by R? It's the data transmit or receive, and DEN is the data enable, right? This structure mainly configures with the data processing or the data transmission to the data transceiver box actually. So these are controlled by the data buses, obviously, because from AD8 to AD15 there are total 16-bit data buses are present. So the DTR mainly process about the firstly the data enable will talk about the transceiver that the CPU is ready to take the data or receive the data, means give the data or receive the data. It mainly controls on that direction, that if the CPU is ready to take the data or receive data, and data enable is that the data which is get transmitted is going in a directed path to the data transceiver box on that. So depending on the DTR and the DEN, we can find that there are three conditions mainly. So the three conditions can be like this: that whether the data is transmitted or not. If it's in zero form, both are in zero, then we can say that the transceiver will not means it will not enable, it will not do any work. If it's in zero and it's one, then it means that the data will be only read, and if it's in both one one one, then it means the data will be write. So that it will work on the write operation. So this is the main configuration of the transmission of data. So based on these two, it is determined whether the CPU is transmitting the data or receiving the data. Next comes the address latch enable. Address latch enable is actually a demultiplexer. Anyone here knows what is demultiplexer? So demultiplexer, he is actually receives a signal input and selects that whether the that input, the output will be in the multiple routes, and it selects the main output route. So actually the what is the work of the ALE? It acts as a demultiplexer which takes that whether the means the input will go to the address bus or the data bus, right? Actually it finds the way that whether it will go to the address bus through the from the address from to the A0 to A0 to A15, or it will transmit the data to the data transceiver box through the D0 to D15. So next comes the control buses, which forms the this last three pins, that is the M10, M by 10, the write, and another one is read, which is not included here. So it depends on it mainly configures on the control buses and how the work will be controlled here. Means there are three conditions mainly. If I0 is 1 and read is 0 and write is 1, then the memory will read the action. If I0 is 1 and the read is also 1 and write is 0, then the memory will write option will be done, write control. If I0 and read are both 0 and write is 1, then IO, that input output, will read. And if I0 is 0, read is 1 and write is 0, then the input output will write. So now it comes the interrupt acknowledge. What's interrupt acknowledge? Previously mentioned by Shashwata, the interrupt command. What is the interrupt command? If a new external device wants to connect with the microprocessor, then this interrupt command will come into the action, and it sends the CPU that, and it forms a logic gate 1 that yes, I can receive or transmit the data, and it gives the logic and gives the request through the interrupt acknowledgements pin. Actually it gives the interrupt request that whether it should accept the data or receive the data, and it's done by the interrupt acknowledge. And next comes the hold. What is hold and hold acknowledge? Hold acknowledge are mainly used by the DMA controllers. What is DMA controller? That is the direct memory access. The memory directly access the pins right here, and to get the control buses, right? When DMA wants to transmit any data, it provides signal to the hold, and the CPU, seeing that the hold signal it provides an acknowledgement like the interrupt acknowledgement, and it gives the hold acknowledge pin. So now we're gonna talk about the maximum mode signals of the 8086 microprocessor. as I mentioned before that when it's maximum, that MNMX here determines that it's maximum or not if the logic is zero, right? If the logic is zero, then MX is the bar of the MN, so MX will give 1 and MN will give 0. So the total, it provides that it's in the maximum mode, right? So here the MNMX is mainly in the grounded form, so the value is 0 here. So here more than one microprocessors can be present. It's the main concept of the main feature, good feature of the maximum mode signal. So the main working is here done by the status signals, right? Status signals used by the 8086 bus controllers, which generate the bus timing and control signals, and on the values of the status signals, we can say that the machine is working on that way. So if the S2 that present here, S2 the bar, S1 bar and S0 bar, if three are 0, then the machine will work in the interrupt acknowledgement. If S2 is 0, S1 is 0 and S0 is 1, then it will do the input output read action. If S2 is 0, S1 is 1 and S0 is 0, then the machine will work and write the input output with the write action. If S2 is 0, S1 is 1 and S0 is 1, then it will halt up. It will just halt up, do a operation, a halt action. And S2 is 1, 0, 0, then the code will access. This is known as also the fetch. So this is known as the instruction fetch instruction is also known as, which means it will fetch the data or it have the code access. If S2 is 1, S1 is 0 and S0 is 1, then the memory will read. Here the IO code was reading, right? Here the memory will read. And S2 is 1, S1 is 1 and S0 is 0, then it will do the write memory. And at last, if all three are 1, then it will do the passive or inactive processor, means bus controller to some other devices. Means it will give the bus controller to other devices. Going on to the queue status, right? Queue status is a processor which actually fetches the instructions, actually, which identifies and dispatches from the queue, which in which the processor provides the queue in this. It mainly works on the FIFO concept. That's the first in first out concept. If QS1 is 0, QS0 is both are 0, then the queue operation will not work. If QS1 is 0, QS0 is 1, then the first byte of an output from the queue gets the first option. As I told, it's the first in, first out, so the first will get the option. So QS1 is 1 and QS0 is 0, then the queue will empty itself. And if both are 1, then the subsequent byte from the queue will start working. So, going on to the last things, we have got the bus request or bus grant. So, okay, before going to the bus request, I must say about the lock signal. What is lock? Lock is actually if any instruction of an output signal is given with a prefix of lock, then that instruction remains locked in that position until that whole instruction is taken place or whole execution of the instruction has taken place. So at last we have got the bus request or bus grant. This is very similar. This is very similar to the minimum mode's hold operation. If the bus request gets the request of any external working or by the DMA, then it holds the request and it provides that if he has granted the request or if it's possible or not, the action is possible or not, it provides with the bus grant option. So thank you. This were all the pins, and we have discussed about the 8086 microprocessor. So if anyone has any questions, you
What
can
is the
ask.
name of the multiplexing?
What, sir?
This multiplexing and then
Multiplexing, I told you, sir, that multiplexing is it's actually receives as input signal and it selects that one of the many multiple outputs, whether which one it should work. Means like the LEE.
multiplexing. Just tell me what is multiplexing. What do you mean by multiplexing in layman's language? Suppose I am having 5 sensors.
Okay.
What does multiplexing do?
we connect all the we connect all the sensors like there is an interconnection and it will process.
So what it does? Also need to.
Don't know, sir.
Okay. So basically, whenever there is multiplexing, suppose we want a particular, it will choose a particular output or a particular data from that five sensors for that example, and it will give one as a result.
One result.
It will process everything and it will
Give the means most
Yeah,
wanted
what's
outcome.
it will give the most desired, like optimal, not optimal. So then,
What is plexing means? Demultiplexing क्या हो?
Demultiplexing is that which gets the input signal and selects one of the main output routes, like the LEE in the minimum mode. It has the
Suppose, as he told, suppose there are five sensors.
hmm,
Your processor has taken five signals, multiplexed, and then it has processed it. Now, finally, what if you do the demultiplexing, what will happen?
suppose in if I give the example of the microprocessor only, if there is an address and there is a data, so the demultiplexer will find that whether the address is transferred to the address
The output. What will be the output?
output.
Demultiplexing करने के बाद what you will get? You have five sensors. He told.
I'll get the desired sensor. Yeah.
Respiration sensor is there.
Hmm.
Okay, and say ECG respiration temperature. Three sensors are there. It has been multiplexed. It has been processed. Now you want an output, and in the output you are having this is a demultiplexer. So what the output should look like?
Its output will look like on the different parameters means
What parameter?
the given input signals means in which way the respiration will go and which way it will the
Yes, sir.
temperature.
Any idea? No. Subhashri, any idea? You are partially correct in terms of the multiplexing. What multiplexing does, it takes the data. Over there, when you talk about this processing the data, everything is 101010. So it codes it, and usually it sends the data in the serial monitoring phase. Okay. So when you are demultiplexing it, again these are three channels. So it is again de-agglomerating it, and it will give you separate channels of data. ये हुआ अच्छा है. How to how the read write operation performs? Tell me the algorithm.
Right operation.
Uh,
Algorithm means if the mi0 is 1, read is 1, then it will the memory will write. Yeah.
So in 0 is 1, yes,
Yeah.
polar. What is happening in the architecture?
I don't know.
Next. I have one question.
Yeah.
So that ALE,
ALE.
that ALE,
Yeah.
based on ALE, it will gauge whether address is or whether it is
Hmm.
what is the status signal for that. So at what time it will act as a address for that? At what input it acts as a data in ALE?
What input?
Yeah, obviously.
Yeah, means if it gets an address from the memory location, means from the
No, I am asking about if it is one, if
Hmm.
ALE is given high input, whether it acts as a address bus or data bus.
uh,
So good morning all. Today we are going to take on our topic that is time series forecasting data driven approaches. So myself Anjo Xavier and myself and my group mate Roman Kumar Vagasia. So the contents are what is forecasting, forecasting model selection and different forecasting models. So that is what we are going to deal in this presentation. So what is forecasting? So most of us have heard a word forecasting with some word related with the climate or something. What is that? Something weather forecasting. So we all have heard weather forecasting, right? So what is that? That's it. So in our systems and all, we can see the forecasting for the coming 5 days. That is the weather forecast for the next 5 days. So how is this forecast done? This forecast is based on the previous data and other related conditions like the cloud conditions, the wind condition. All these parameters are taken care along with the previous data, and we are getting a future forecast. That is what we are doing in that. So forecasting, in another example, if I am running a laptop work, so a laptop repair center, and I am having workers. So how the workshop run is that the people will be sending the laptops to me, and I will be repairing using my workers, and I will sending them back. So some of the days the number of laptops coming for repair will be more. So I will have to adjust my worker number of workers according to the load of the work. So if I can predict that on this day this much number of laptops will be coming, and on this day this much number of laptops will be coming for repair, I can adjust my number of workers earlier, so that the efficiency of my service center will be more. So for these kind of activities and other role, we are using the forecasting. And when it comes to signal processing, the signals also can be represented as a data set, where like we can represent it using a timestamp, and at that timestamp what will be the value. So like that we can represent the signal as a time data in a table, and using these models of different forecasting models we can predict the future signal what is coming to arrive. So then how the forecasting model is selected. So the first point is time horizon to forecast. So considering if I am having a 6 week data, like a 6 week sales report. So using that 6 week sales report, previous report, I can predict the 7th week, the 8th week, the 9th week, etc. But as we move on from the 7th week, the accuracy of our prediction, it will be less, because we are using the previous data to predict a more time ahead future data. So as the time horizon moves, that is from if we are taking for less time horizon, the accuracy will be more, and if you are predicting a larger time horizon forecast, the accuracy will be less. So we can calculate the accuracy by the error. So when it comes to the 7th week, the error will be less. When it comes to the 8th week, the error will be a little bit more, and when it comes to 9th week, the error will be greater than of that of the 7th and the 8th week. Then comes to the data availability. Data availability is a very huge contributor to the forecast, as the amount of data can have a huge impact on the forecast. So if we are having a data of more than consider of 1 or 2 months, considering the accuracy of the 6 week data, the 2 months data can provide a more accurate forecast. Then comes to accuracy. In accuracy, we can decide the model using our the amount of accuracy that we need. Like if we are taking some sales case and all, we can limit, we can adjust the accuracy, because um, in that the accuracy is also budget oriented. So if we need more accuracy, we will have to adjust the budget. So for like the signals, like biomedical signals, we should have a high accuracy, because it is biomedical signals, so accuracy should be more. But when it comes to the sales activities, the accuracy can be varied, because there is not much importance considering to the biomedical signals. The sales accuracy of the forecast is can be
You already have the previous data. How will you change that data to improve the accuracy?
sir.
You already have the previous data,
Yes, sir.
past data.
Uh.
How do you improve the accuracy?
Sir, we can select the model according to the accuracy needed. We are talking about the model
Regarding
selection.
budget.
So,
When we talk about budget,
um,
it's about manipulating the previous data.
not, and along with that, the mod for each model, the computational requirements are different. So, for higher accuracy, we need higher computational so that the budget will be more.
You mean to say the budget is the computational complexity if you increase it.
Yes, sir. That is in the next point. The size of the forecasting budget. So if we have, if we need more complex computational models, we need higher budget. So we need to have a equilibrium between our what we gain from this forecast and what we are investing for this forecast. This should be in an equilibrium. Then comes to the availability of qualified personnel. That is also a important matter because we are in complex model. We need to fix a constant and all. So highly qualified personnel with a high experience can give a more equilibrium constant that can improve the accuracy of the system. So these are the forecasting models that we are going to look on this in this. The forecast models are naive forecast, simple average, weighted moving average, exponential smoothing, and Hall's exponential smoothing. So Roman will take care.
Now we are discuss about the different types of forecast. The naive forecast is the simplest one. The forecast there is a we have to predict the future value means f n plus one. Like forecast the next value that is the same as the actual value of the prior R. I have to see one example here. See here the demand. I have to forecast the week of 5. So in the new forecast, uh, the it is equal the forecast is the same as the previous week of the here we see the 720 is the previous week of data. Uh, so it forecasts the same as the previous week data. You can see here. So this is the simplest new forecast. Now we have to move forward to make the accuracy higher. So we have to look here the simple average model. In here what it look like that can average the whole data means it has a 5 week data 4 week data, so it can average whole data and can make the predicted data means it can forecast the next data. So I have to see, look here in the picture in the table it has a 4 week data, so it can the simple average filter, simple average forecasting, simple average model what it can predict the next value, what it can predict the next forecast. So the 4 week data it can average means the sum of that four demand sum of that four demand value and then divide by the average of that, so it can get a simple average value, simple average of forecasting. uh, okay, now we have moved forward to the we are talking about the accuracy. In the simple average there is an no मतलब it has a less accuracy for the forecasting data. Now we have moved forward to the simple moving average forecasting. Here we what about talking about it has we have discussed about the windows, right? We have discussed about the windows. It can select the 4 or 5 particular data and can average it to it can average and then get forecast the data and can forecast the next data. So here we can talk about the simple moving average. It can uh, forecast the next data for the particular in particular windows means that it can 3 data or the 4 data or 5 data or 6 data or likewise we have to want what we have to want, right? Mm, see here the 2 3 and 4 I have select the 3 windows. I have select the 3 values as a my window means moving average. So I can average these three demand and it can forecast the next it can forecast the next value. So it shows this. And here we talk about the weightage of these different discuss about the different values, different weak demands, right? It can allows the weightage of each values are the same, right? Because it can there is a simple average, right? So if I can choose the three data, so it has a weightage of 0.33 0.33 0.33, so it can forecast the next value as the that is a not much accuracy, but it can forecast the nearer closer to the actual forecasted. Okay. Now we are moving forward to the weighted moving average. Here we see that the word is weighted moving average means that we have to set the weightage of the we have to forecast the data. So previous data means I have to forecast the fifth week of data. So I can weight the fourth week of data. It has a higher weightage for that, and later on I can set the weightage of the a point 3 point 2 point 1 whatever I want it to okay. So I have see
Can
the
you give an
here.
example of weighted average
What's
moving
that?
average? Can you give an example of yeah, this weighted average?
Yes, sir. I have explained the weighted average example, sir, here. So my weightage is here. First we have to talk about the weightage, right? So the sum of the total weightage is equal to 1. So we have to set the sum of the total weightage is 1. I have seen we have to explain about the I have explained the example of here. So I have the 4 week of data here. So I can weighted every each value has some particular weightage. So I can weighted a fourth week of data is a zero point 0.5 weightage here. I can set the point 0.3 weighted point 0.3 value as a weighted of week of 3 and point 0.1 and point 0.1. So later on, so the my forecasted data is much more accurate, accurate to the prior fourth data. So it gives then higher accuracy means it has a lots of higher मतलब कि, most of the roles are their data has a most role of the fourth week data. It allows it can forecast the data which has a more higher the value of the previous data, but in the later on there is a 3 2 1, it has a lower compared to the fourth one. So here we can see the fifth week of data. I can multiply the week of data with the weightage of zero point 0.5, third week of data with the weightage of 0.3,
Why you
to
want to do this?
huh?
Why you want to do this?
To make a higher accuracy,
How to make
higher
it?
accurate weightage,
How?
higher accurate forecasting.
How?
So to multiply with the weightage we have मतलब कि prior fourth week of data we have it takes what I'm saying uh,
So the data that was just previous, the forecasting data will be having more weightage, because if we are
Why?
considering a sales
say,
report, the sales of the previous month will be having more effect on the forecast than the than the
in
sales of
the
the months
previous weeks of
before that.
data
So we are setting the weightage in a reversing order. So the
the मतलब कि present value has a more higher weightage to can forecast the next value, to can forecast the next value. In the later on there is a old values, there has a I have set the less weightage to can affect the accuracy of their next it can affect the accuracy of the next forecasting data.
Is
Here we
there any
can
assumption associated over here?
assumption.
Why you want to do this? Why
mm,
you want to take more weightage of the recent values and not the.
Sir, here we can see in the graph, sir. uh,
Okay, graph is okay,
hmm.
but why you want to do this? Any assumptions are there?
Any assumptions, sir? If I'm sir, Enzo
the
says that I
You
can
are comfortable in Hindi, you speak in Hindi. Not a problem.
ओके सर. अगर मैं मतलब कि यहाँ पर आज मतलब कि मेरा 7 एंजो साइज के कोई लैपटॉप मतलब कि रिपेयर कराना आया है. So today that gave me 20 laptops for the repairing. The last day they gave me 18. In the order there is मतलब कि starting of the business there is a less of amount of the repairing and calls. So I have to predict means the कल मतलब कि क्या मतलब कि कितने laptops आएंगे मतलब कि रिपेयर कराने. So I have to assume that because the last is the मतलब कि पहले मतलब कि business शुरू किया था तो मतलब कि तब मतलब कि इतना
But if you see your own data over here, what you are presenting, it
हाँ
is
हाँ
cyclical data, really cyclical data.
हाँ सर मतलब कि in the fourth week there is a 720 laptops here. So I have to predict that in the fifth week I can nearly the 700 laptops are coming, right? So I have to make
No,
that.
if you see your this thing,
Hmm.
uh, if you go back one crop year where there is a decrease in the year, what do you call
Demand.
values, so
Huh.
it is coming to a minimal point. If you whatever you are doing, if you are whatever what do you call apply that logic over here, then your data should have come down. However, your data is going up.
Yeah. हाँ सर is it मतलब कि I have to set ना weightage sir.
That's
First
what I am telling.
that
When your
there is
data
there is
is
a more
coming
data.
down, and you are taking this more average weights for the latest data, then your prediction would be it should be going coming down. But your data is going up.
Yes sir. So better
So
is
are
to
there any assumptions?
so better is to make a larger data sir. Well, make better is to use the more amount more week of data to make a prediction of the.
Go through that.
Uh-huh.
Next.
Now I have moving forward to the exponential smoothing. So the previous models can give a fluctuation in the model, right, sir? Fluctuation in the forecasting data. So I have used the there is a model of the exponential smoothing model. It can predict the next forecast to the basis of the actual value of the previous actual value and the previous forecasted value also. So here you can see the it is the previous actual value and the ft is the previous forecasted value. So the alpha is the weightage means here is we use the alpha is the constant we have set as a weightage. So alpha is generally between the 0 to 1. So if alpha is higher means nearly to 1, so it can act like naive forecasting. It simply is just actual it can set as the actual value. I have previously I can talk about the 720 is the fourth week of data, so it can fifth week of data it can store as a 720 of the forecasted value. So it can act as a naive forecasting. But if my alpha is become in nearer to 0, so it can more likely to depends on the previous forecasted data, okay, and the less of the previous actual data, and that can smooth the forecasted value. Here we can see in the graph there is a blue is the actual blue line dotted is the actual my value actual values of that, and the red
What is exponential over here?
exponential
In the formula, it is 1 minus alpha to the power star. What is that to the power star?
no sir,
It is multiplication.
multiplication sir, multiplication star. So here we can see in the graph there is a red line. It indicates the alpha is a much higher means closer to the 1. So it is the naive forecasting naive forecasting. It has a much higher uh, much higher accurate much higher what I'm saying it can it can has a it has a role of the higher actual data of the higher actual of the previous week of data, and that has a fluctuation in it. You can see here there is a lots of fluctuation, but we have to talk about the smoothing. So we can set the alpha as to nearer to 0. I can set mainly use the 2.2 2.4 alpha to predict the next next forecast next predict the next value. So alpha is nearer to 0, then you can see here the yellow graph that can smooth it down to the forecasted value. So here you can see the triangle one, the triangle mm, there is a alpha value of 0.2. So it has a mhm, smoother. Now the next is the Holt exponential smoothing. It can talks about it can talk.
So Holt's exponential smoothing. In the previous exponential smoothing, we were only considering the f of t plus 1, and it is the level. We will call this as the level in the Holt's exponential smoothing. So when it comes to Holt's, we need to take into consideration two more things, that is the trend and seasonality. So it is the system is mainly divided into two parts. One is systemic and non-systemic. In the systemic manner, we will consider the level, trend, and the seasonality. Level is just the previously forecasted value, that we are giving a new name to the previously forecasted value as level in the Holt's method. And in the trend is nothing but, here we are having no seasonality. This shows only the how the level works. So this is a normal signal or normal wave, and when it comes to additive wave, the wave will be having a linear motion. Linearly it will be increasing, and when it comes to multiplicative trend, it will be in a fashion like this, so of a logarithmic fashion. And when it comes to polynomial trend, the signal will be having a polynomial fashion. Then when it comes to seasonality, this shows the seasonality, and here there is no trend in this one, so we can find what is seasonality. So this is the normal, and when it comes to seasonality, in each season the value will go high, and it will come down in additive seasonality. And in multiplicative seasonality, as the time passes, in first one the seasonality, as the season comes, the value goes high and it goes low, and in the next season the value goes higher than the previous season, and in the next one it goes more higher than, when comparatively it goes higher and higher. So this is the uh, idea of seasonality and trend. And in this exponential, we will be considering the trend value also. The level and the trend will be considered in the Holt's exponential model. So when it comes to additive, the forecast will be based on level plus trend plus seasonality plus noise. Noise is unpredictable, that's why we cannot add in our equations. And when it comes to multiplicative, the forecast will be like the level will be multiplied by the trend, and it will be multiplied by the seasonality, and it will be multiplied by the noise. So we will understand it later. So this is the equation of the Holt's exponential smoothing. The f of t plus 1, that is the forecast of the next one, will be based on the level of the current data and the trend of the current data. So in each step, we will have to update our level and our trend. So the level can be updated by level will be equal to alpha into a of t, that is the actual value at the time t, that is the actual demand at time t, plus 1 minus alpha into l minus t, l of t minus 1 plus t of t minus 1, that is the level of the data, that is the previous level and the previous trend. As you can see, this is almost like a weighted averaging, like, because alpha and alpha minus 1, and if we add alpha and alpha minus 1, we will get a value of 1. So we are giving a weightage of alpha to the previous data value, demand value, and alpha minus alpha 1 minus alpha weightage for the level and trend of the previous data. So adjust the previous level by adding trend. So the level will be adjusted by adding the trend. So when it comes to trend, how we are updating the trend is like B. Here we will be adding one more constant, that is beta. Beta into level of the current one plus level of the previous one. It will be multiplied with beta, and 1 minus beta into trend of the previous one. So here when the trend is a fast moving trend, like if it is going more linearly, we need to adjust the value of beta in such a way that it is higher, so that we can fastly learn the trend. That's why we have to adjust the alpha and beta value according to the data. The previous updating the previous trend using the difference between the most recent levels. Trend can vary adaptively or over time, and beta controls the speed of adjusting to the trend. So this is how the additive trend and multiplicative trend works. The forecast is equal to the most recent estimate. Sir, over, sir. Forecast is the most recent estimated level plus estimated trend. And that is the additive trend. That is f of t plus k, where k represents the number of steps ahead we are forecasting. And in multiplicative trend, we will be multiplying both. That's it. So these are the references. Thank you.